I'm going to guess this is going to be a really long video. Solving trig equations, trig formulas, trig graphs. It just sounds like a lot of fun. Oh my God, all this trig. Oh my God, I'm so excited to get started and do 9 pages and 59. I can't even imagine how long this video is going to take me. 59 questions. Look, man, if you can go through this entire thing, spend a couple of half an hour, 45 minutes at a time, go through, check these trig questions out, you'd be like a genius at trig questions at the end of this. It's all just trig. Sine, cosine, tangent, secant, cosecant. Ooh, who invented this crap anyway, right? Seriously. All right, we better get started. Look, if you enjoy my videos, okay, scratch that. That's not going to happen. It's math. It's not like, you're watching Rob Dyrdek do a little ridiculousness, or whoever that guy is. It's math. So let's just say you gathered some information from me and you appreciated my hard work to put all this together for you. Hit the subscribe button. Always interested in subscribing. If you're, by the way, peeking at my videos and you're not subscribed, seriously, you're not doing me any help. You're not doing. Just hit it. Just go. Now you're subscribed. Now I feel better. The other thing is, if you're already subscribed, then hit that little button with the thumb up. Not the thumb down. Okay, that's thumb. No, up. If you hit the thumb down, you might fail. Just saying, it might happen. So you might want to hit the thumb up. That means your grade's going to go up. You see what I'm saying? All right, kids. Here we go. Lots of fun. Lots of trig. By the way, mrkrausmath.com / no, don't slash it. I have no idea how to do slash. But click on the Regents Review. mrkrausmath.com. Kraus is Krause. It'll be probably in the show notes somewhere. Click on the Regents Review, and you can download this PDF. It's 9 pages. I apologize for killing trees, but hey, if you pass this trig final, maybe you'll get a great job someday, and then maybe you'll be able to figure out how to make paper without making paper, then you'll be able to figure out how not to kill trees, and if we figure out how not to kill trees, maybe you'll be a millionaire. So you see what I'm saying? It might help. Let's get started. Here's what we got. Sine B equals this, and they want 2. Anytime you say 2 of an angle, anytime, cosine 2b, sine 2b, tangent 2b, that means you have to go over to your formula sheet and take a look at it. And that is right here. Cosine's got 3 of them. You get to choose your poison. So since we already have sine, we're going to use this third one, because that's the only thing we have. 1 minus 2 sine squared theta. I forgot to start my calculator. Oh my gosh. So cosine 2b, or not to be. Oh my God, a little Shakespeare at you. 1 minus 2 sine squared b. Now, if you don't like that, it's really the same as this. 2 sine of b squared. Well, all right, then that shouldn't be too bad. Sine of b is just 2/5. Now, it's not sine of 2/5. Sine of b is 2/5. And then we got the Gravitationrechner, our calculator. Hopefully that'll be up soon. Oops, wrong. Right. And I will figure out what this is equal to. Let's say 4/25. That's going to be 8/25. 1 minus 8/25 is somewhere around, was that 17/25? Let's see. Go into the calculator. 1 minus 2 parenthesis 2 divided by 5 parentheses squared. Oh, 17/25. There it is. My answer, 17/25. All right, next one's not so easy. Let's just go down. Let's go across. I'll go back and forth until it doesn't make any sense. The area of a parallelogram. Now look, kids, you are in trig. Algebra 2 and trig. Not in algebra, not in 4th grade, not in whatever. You only know one area formula. It's on your formula sheet. It's right here. But it's the area formula of a triangle. So you need to remember that a parallelogram is really just 2 triangles. So you're going to use the same formula, you just got to get rid of the half. So it's the same work. So I know that my area formula, I know I'm going to use this formula, K equals 1/2 a times b times the sine of c, except we're not going to use the half. We're just going, because it's a parallelogram, we're not going to use the half. So 684 is equal to 32 times 26 times the sine of c. Now, I changed a few of these problems so that they wouldn't be the exact same things that are in your green books. So if they don't work out, I apologize ahead of time. I tried to get them as quickly as possible. But, so we're going to divide. Oh, I'm going to figure out what this is. So let's go over to my calculator. And we're going to do control division. Oh, excuse me. We're going to do a little citral division. 684. Yeah, had one daughter. Sorry, Jordo. Had one kid, wanted to call that the citral button. She's a lot of fun. I forgot what the numbers are. 32 times 26. 32. Oops, crap. 32 times 26. Hopefully this is not over 1. Yes, it's not over 1. So then what I got to do, I've got to go back to where I was that 171 over 208. So what I have now is I have the sine of c is equal to 171 over 208. I don't like the sine being there. It has to come over here. Has to. When sine changes the side, it becomes the inverse sine. And really what you're doing is taking the inverse sine of that. But it's just, if you want to think about it changing its sign, sort of, and bringing it over to the other side, that's okay. So we're going to inverse sine this. So I'll go back to my calculator. I got to inverse sine this answer. And I get 55.297. 55.297. 55.297. Oh, and then near, oh, man. They want it to the nearest 10 minutes. I think I was being a jerk on this problem. So I got to DMS it. So I go into my catalog, I find DMS, click on DMS, and to the nearest 10 minutes. So that's 55 degrees, 17 minutes. To the nearest 10 minutes would be 20 minutes. So my answer is 55 degrees. I'm doing it in green. 55 degrees, 20 minutes. There she is. All right. Next problem. So I went to 6 just because this problem's so hard. Oh my gosh. Let me distribute. So I get sine squared x. Now, isn't cotangent squared cosine squared over sine squared? So when I multiply sine squared times this, the sine squareds actually cancel, and it leaves me plus cosine squared x. Well, we know that's equal to 1. That's a Pythagorean identity that we just have to know. So secant squared, let me distribute secant squared. So secant squared, so I'm going to do secant squared x times the 1 minus, now secant squared is 1 over cosine squared, and I'm going to multiply by sine squared x. Well, this becomes secant squared x plus tangent squared x. Now, does this equal 1? Well, there is another identity that you have to know. The most important is the sine squared plus cosine squared equals 1. But the two others that are incredibly important is that you remember that tangent squared x plus 1 is equal to secant squared x. Well, if I remember that, then this, when I bring it over to the other side, gives me secant squared minus tangent squared. I don't know why I put a plus, it's minus. And that equals 1. I'm going to distribute. Now this is cosine squared times sine squared x over cosine squared x. So these cancel. This leaves me sine squared x minus 1. I'm not really sure what that is. Well, let me come back to that one. So cotangent squared times secant squared. Let's see what that is. So this is really cosine squared over sine squared times 1 over cosine squared. So these cancel. And that leaves me 1 over sine squared. But 1 over sine squared is cosecant squared x. And then if I distribute this, minus cotangent squared x, does that equal 1? Well, if you go back, I forgot the last one. The last one is cotangent squared x plus 1 is equal to cosecant squared x. Or, in other words, 1 is equal to cosecant squared x minus cotangent squared x, which this is. And so 3 is the right answer. Woo! So, having said that, let me go up here and tell you 3 things you must commit to memory. The first one is cosine squared x plus sine squared x equals 1, which gives me, when I bring the cosine over to this side, sine squared x is equal to 1 minus cosine squared x. Or, in other words, cosine squared x is equal to 1 minus sine squared x. So the thing you have to remember is this one, because it will give you these two. And this is on every single trig test there has ever been. So if you don't commit this to memory, now I have flashcards that could help, but if you don't commit this to memory, something's wrong with you. The other two that you have to remember is tangent squared x plus 1 is equal to secant squared x. Now, I never remember that one. I do, but that one's the hard one. The easier one is cotangent squared x plus 1 is equal to cosecant squared x. Now, I just matched the C's up on this weird trig identity, and then the T and the S are close together in alphabetical, so maybe that's how. Commit them to memory, kids. You got to. All right, let's move on. I'm going to do 7, I guess, first. Amplitude. Well, the first thing I got to do before I find amplitude is actually find this midline. I'm going to do this in red. So the midline, the highest point is 4, and the lowest point is -2. So that difference is 6. So I want to come 3 down. If I go 3 down, that will tell me where the midline is, right there. How high I go up from there and how I go down from there. So my midline is y equals 1, or just 1. Now, the amplitude then is, quite frankly, just 3, because it goes up 3 from the midline, it goes down 3 from the midline. Frequency, if you remember correctly, this is how many curves in 2 pi. So if I look at this, this looks like I'm finishing one full cosine curve. This is a cosine curve because it starts at a max, ends at a max. Could it be a sine curve? Yes, if with a shift left or right. But we're going to go with the simplest, and this is a sine curve, or a cosine curve. And it finishes one full curve in pi, which means in 2 pi it would finish 2 curves. So my function, f of x, one possible function is my amplitude, which is 3. And since I started a max, I'm going to have a positive 3. Cosine of 2x, because the frequency is 2, plus 1, because the whole thing got shifted up 1. All right, there it is. Angle theta in standard position. Angle theta is in standard position, and 0, -4 is a point on the terminal side. Well, you need to remember that standard position of an angle starts with its initial side on the positive x-axis. So this has to be the initial side. Now it says the terminal side, which is the end side, goes through 0, -4 down here. So standard position means we're going this way, and we're going to go through that point. So you need to know this is 270 degrees. And the question is, what is the cotangent of the angle? Well, the angle is 270 degrees. So you can either memorize it or go to your calculator and go cotangent 270. 0. Done. If they had asked the tangent of that, you would have had to say undefined. Oh, gosh, look what we got here. Same thing, same question, same point. So I try to make it easy. But this time I'm asking a different trig function. So 270 degrees. But I got to do cosecant. So I come back over my calculator and I do cosecant of 270 degrees. -1. There it is. So this answer is -1. Okay. Determine to the nearest minute the degree measure of this. So this is what I have in radians. 3 pi over 5. And to convert from radians to degrees, I have to multiply by 180 over pi. So this goes and this goes. Oh, and I said to the nearest minute. Well, this was kind of a dumb question. I should have made this more difficult. 36, 100 is 108 degrees. Let me just check. The pi's cancel. Let me just check to make sure I'm right. 3/5 times 180. Yeah, 108 degrees. So to the nearest minute, it would be 108 degrees, 0 minutes. I meant to make this denominator a little less exciting. So that's the answer. I mean, to get it to the nearest minute, you'd have to go 0 minutes. All right, let's talk about this problem. Do you see this double angle formula? Every time you see that, you have to go to your formula sheet. And there's only one. It's right here. The sine of 2 theta is 2 sine A cosine A. Forgot what I was doing. Minimize that. All right, I'm already 17 minutes in on one page, and there's 9 pages. This is going to be a long video. So this is cosine of theta is minus, I don't know why I did that, solve multiplication. And this is what I'm replacing. 2 sine theta cosine theta equals 0. Okay, well, the first rule of factoring says take out the GCF. In this case, the GCF is cosine theta. And it leaves me 1 minus 2 sine theta. Remember, we're taking this out. This leaves me a 1 here. Equals 0. Well, now I just set each of these equal to 0. Cosine theta equals 0. And then this one will give me sine theta equals 1/2. Now, on the cosine, you got to remember what the cosine curve looks like. It starts at a max, ends at a max. Its 2 points when it's 0 are at 90 degrees and 270. This is 0, this is 360, and this is 180. So 2 of my answers are going to be 90 and 270. Now, you have to know when sine equals 1/2. Now, I know it, I have it memorized that it's 30 degrees, but if you don't, then you've got to inverse sine 1/2. And if you do that, you get 30 degrees. So, the other thing you need to remember is when is sine positive? Okay, there's a little fun mnemonic device for that. All students take calculus. Sine is positive here. Everything is positive here. So, I want to keep that 30 degrees, but I also want the angle in the second quadrant, and that would be 150 degrees. I'm not going through how to get that one. If you can't find an angle in a quadrant when you have the reference angle, go back and study. I don't know. You're going to have to figure out something. Maybe your teacher's got some review sessions where you can review that. All right, so this whole page is nothing but graphs of things you have to memorize. So we're going to try to compare them. We're going to try to match them. Starts at a max, ends at a max. That's cosine of x. We'll come back to that bad boy. The one of these wiggle graphs, these wiggle ones that look like waves, these two, they are either tangent or cotangent. And what I want you to remember is that tangent is the one that goes through the origin. Tangent is the one that's symmetrical with the x-axis. So that makes this one cotangent. So going up, tangent, coming down, cotangent. So that's tangent. This is cotangent. Now, this one is either got to be secant x or cosecant x. And the way I remember it is I put dots on all of these points. And then I graph it. And I say, okay, which is the curve that starts at the origin, goes up and back down and back up? And that is sine. So that red curve is sine, and the the reciprocal function of cosine or sine is cosecant. So this is cosecant x. So while I'm here doing that, why don't I do these dots then, right? Forgot to go in the middle. And I didn't put the asymptotes here. Sorry about that. If I had put the asymptotes, it would make this easier. So start at a max, end at a max. This one's cosine, the red, so that means its reciprocal function is secant x. These are almost all inverses over here now. This is just tangent, sort of laying on its side. So this one, you have to remember, it's the wavy function, so it's either got to be tangent or cotangent. They'll never ask you about inverse cotangent. They'll only ask you about the inverse of sine, inverse of cosine, and the inverse of tangent. So this is tangent -1 of x. Let me go to this one first. Do you see how this one goes to the origin? Now, which one of the two trig functions goes to the origin, sine or cosine? Sine. And since sine goes to the origin, its reciprocal function also goes to the origin. So this one is sine inverse of x. This one goes to the point 0, 1 to start, so it goes to the point 1, 0. So this is the cosine function goes through point 0, 1, so it will also go to the point 1, 0. And so this is the cosine -1 of x. Now you may just want to memorize them. That's probably the easiest way to handle that. All right, let's go back to all students take calculus. All students take calculus. Sine, this does not mean less than 0. This means negative. And sine is negative in the third and fourth quadrant. This means cotangent is positive. Cotangent's positive wherever tangent is positive. Everything's positive here, and tangent is positive here. Big winner, number 3. So let's talk about this curve. I didn't give a lot of room, so you're going to have to use your brain. This is the cosine curve. It's got a negative leading coefficient, and it's got a positive 4 shift up. So we're going to have a midline of 1, 2, 3, 4. There's my midline. That's the thing that goes right down the middle of my cosine curve. My cosine curve has an amplitude of 2, but it's coming down 2. So it's going to start at its minimum. Remember, cosine starts either at its max or its min. In this case, it's going to start at its minimum, and it's going to end at its minimum. In between, then, it would be at its maximum. So the cosine curve for the negative would look like this. Well, if this is 4, I'm going up 2 and down 2. And that's the range. So the range, the lowest the range is going to be, or the lowest the y values are going to be, is 2. And the highest the y values are going to be is 6. So 2 to 6 for the y values. Oh, that's x values. No. We're looking for 2 to 6 for y values. There it is. And this is -6 to 2. So we want 2 to 6. So the only answer is choice 4. The domain's easy. It's just all reals. But they tried to convince you, confuse you. Let me go to this one. cosine x plus y. If you ever see sine x plus y, cosine x plus y, tangent x plus y, it's on your formula sheet. You got to go over to your formula sheet. It's right over here. Cosine x plus y. It's cosine A, cosine B, sine A, sine B. So, gotta go back. So this is equal to, remember, cosine is going to be cosine, cosine minus sine, sine. So in this case, it's cosine x times cosine y minus, because that's what the formula said, it says it has an opposite sign, sine x sine y. Now I know the formula sheet used a and b, but we don't have a and b. We have x and y. So, do we know some things? I think we do. What is cosine x? It's n. What's cosine? Oh gosh, guys, this should say cosine. This actually should say cosine y. This actually should say cosine y. I got to fix that. So cosine y is also equal to n. So if I didn't make that change on yours, I apologize. It should be cosine n equals y. Cosine x and cosine y equal n. Sine x and sine y both equal m. Wow, what is this? This is n squared minus m squared. Oh my gosh, I did it wrong. I got to switch this around. Okay, I'm going to guess, hopefully if you're looking at this document online, that this is going to be changed to n squared minus m squared. I knew when I changed this problem, I should have checked some of these answers. This should be n squared minus m squared. I apologize. That's what that one is. Hopefully there's not too many of those. We're going to convert 1.9 radians. So to convert from radians to degrees, you have to multiply by 180 over pi. Now, if you remember correctly, 3.14 radians is 180 degrees. So this is about half, or a little less, a little more than half. So it should be a little over 90 degrees. We're going to figure out what this is equal to. And if you come up with some ridiculous answer, you'll know you did it wrong. So this is 1.9 times 180 divided by pi. 108.86. 108.86 to the nearest minute. Got to DMS it. Now remember, our cutoff is 30. This is 43. So it's 108 degrees, 52 minutes. Remember, the cutoff for these is 30. It's a flashcard. If you don't have my flashcards, figure it out. So 108 degrees, I think it was 52 minutes. 52 minutes. Now, if you had accidentally screwed up and multiplied by the wrong thing, let's say you took 1.9 and you multiplied by, and I'll make it look nice this time. Oops. You took 1.9 and you multiplied by, I hit the wrong thing. How did I hit division? Times pi over 180. Let's say you screwed up and you typed in the wrong thing. Let's see if this answer makes sense. Oh, look, I've got 0.033 degrees. It doesn't make any sense, right? Okay, so if you screw up and you get some ridiculous decimal, you either got to make sure you're not in radian mode, which we're not, or the fact that you didn't type that in right. So there's the answer. Sine, okay, so this is similar to the question number one. If you remember from question number one, sine, cosine 2 theta has 3 different possibilities. They're all right here. They're all right here. And we're going to pick the one with sine in it. I don't know why I didn't pick different ones. But anyway, so cosine 2 theta is equal to 1 minus 2 sine squared theta. So this is going to be equal to 1 minus 2 times sine squared. Well, what is that? It's negative 1/4. So I type that puppy in my calculator. 1 minus 2 parenthesis, control division, negative 1 over 4 squared. 7/8. Yay! I hope that was one of my answers, because otherwise I screwed up. 7/8. All right. Cofunctions, cosine and sine. Cosecant and secant. Secant. Cotangent and tangent. Let's call these x's and these y's. Are always equal to each other when their angles, x plus y, add up to 90 degrees. Something you must memorize. This comes up quite frequently. It's usually a 2-point question. It's pretty easy. So I'm going to show you 2 different ways to solve this one. One, I'm going to show you the easy way, because sometimes it's a part 2, so you need to know this way. These 2 just have to add up to be 90 degrees. So 4x plus 8 plus 2x plus 22 have to equal 90 degrees. So this gives me 6x plus 30 equals 90 degrees, or 6x equals 60, or x equals 10. The other way to do it would just be to plug the answers back in. And this would be 48, so cosecant of 48, and then cotangent of 42, and you'd find out those are equal. This question is never a part 1 or part 2 question. It's always a part 1 question. The one thing you need to remember is this arc tan is really just like some old dude's way of saying tan negative 1 of k. All right, so for the smart kids, which is a lot of you because you're here watching my videos, so you can't be dumb. You got to be kind of smart. The sine of what angle is equal to radical 3 over 2? Well, I know that the sine of 60 degrees is equal to 3 over 2. So the tan inverse of what will give me that 60 degrees, which really is what's in here, because that's what tan inverse is. So if I remember correctly, and I'm not mistaken, I believe that the inverse tan of the square root of 3 is 60 degrees. Now, am I expecting many of you to remember that? Oh, no. Most of you, when you see arctan, will start to do this. Skip, guess, don't know. But learn to use your calculator. Now, you can't use your calculator if you don't remember that arctan is really tan inverse. But if you do remember that, then you come down to your calculator and you go, okay, I'm going to work backwards. It says sine of inverse tan. And I'm going to just try one of the answers. Well, I know the answer is the square root of 3, so I'm just going to try that one first. Square root of 3. And it equals, what is that? Well, if I look over at the problem, it said it equals square root of 3 over 2. Well, I wonder what the square root of 3 over 2 actually is. So I do the square root of 3 divided by 2. There it is, square root of 3 over 2. So it equals. It equals. If I also had this, I could also say, hey, take this, and I go menu, number, approximate to a fraction. Oh, no, you can't approximate that to a fraction. It won't. It won't. Well, that's, I guess, your best approximation. Because this is irrational, you really can't get a fraction. I mean, this is sort of a fraction, but that's not going to work. You just have to see what the square root of 3 over 2 is. All right, done. What is the number of degrees in the angle whose radian measure is 7? Here we go again. And then so 7. Let me get this away from my big fat head. Oh, I skipped a problem. I skipped the problems. 7 pi over 5. So 7 pi over 5, to convert from degrees to radians, you got to multiply by 180 over pi. Pi's cancel, and I'm ended up with 7 times 36. I don't know what that is. So 7 divided by 5, and then times 180. It's going to make it look funky, but it's right. 252 degrees. So that's my answer. 252. Anytime I get a cosine or sine or whatever curve, the first thing I want to do is find the midline. All right, so in this case, the maximum height is 2, the minimum height is -2. That means the midline is right here in the middle. So there really is no midline. Well, that's great. There's no midline. So that has nothing to do with the problem because none of the answers have midlines. So because it's starting at a min and ending at a min, not starting at 0 and ending at 0, starting at a min and ending at a min, it has to be a cosine curve. And negative, negative. Okay, now the other thing is the frequency. This number here represents the frequency. The frequency is the number of full cosine curves in 2 pi. Well, that's one cosine curve in 1 pi, 2 cosine curves in 2 pi. There's your answer because it has a frequency of 2. Choice 3. All right. So, do you remember me telling you a few minutes ago, anytime you see cosine of something being added, I'm going to show you 2 different ways to do this problem, by the way. I'm going to show you the hard way and I'm going to show you the easy way. The hard way I'm going to show you only because this easily could be a part 2 question where you don't have multiple choice answers. So, how am I going to do this? Well, I remember my cosine function right here of a plus b is cosine cosine minus sine sine. I got to remember that. Cosine cosine sine sine. So I'm going to go back to my sheet. Actually, what I'm going to do is pause. Oh, I'm in the wrong thing. So I'm going to use that notation. Oh man, I messed up. Readings review assignments. There it is. I'm going to use that formula in order to solve this equation. Sorry, I went back and I wanted to make the correction on that one problem because it was bugging me so much. So if I remember correctly, this is cosine cosine minus sine sine. So it's going to be cosine of the first angle, theta, times cosine of 90 degrees minus sine of theta times sine of 90 degrees. So this is cosine theta, nothing to do with that, but the cosine of 90 degrees is 0. I hope you know that. Minus the sine of theta times the sine of 90 degrees is 1. So this goes away and I end up with 1 times sine negative 1 minus sine theta times 1 or minus sine theta. And that's the answer. Now the other way to do this problem is just to take some angle. Let's say 10 degrees. Just make it 10. And I'll come over to my calculator and okay, I'm going to store 10 and I'm going to store it into x. And then I'm going to say, okay, cosine of x plus 90. Okay. Negative 0.1, blah, blah, blah. And I said the answer was negative sine of the angle, right? So I'll go negative sine of x. Easiest way to do it is just to work backwards from the answers. It's not a problem at all. All right, but I wanted to show you just in case you had to do a part 2. Hey, is that page 2 done? I think we're moving to page, no, I think this is page 4 or 3. An angle A drawn in standard position terminates in quadrant 2 if, oh my gosh, I got rid of the multiple choice answers. All right, so what I'm going to do is I'm going to give you the multiple choice answers. If 0 is less than or equal, or no, is less than theta, oh, I should be using A. So here's the multiple choice answers. You're going to decide. If 0 is less than A is less than pi over 2. If pi over 2 is less than A is less than pi. If pi is less than A is less than 3 pi over 2. Or if 3 pi over 2 over A, 3 pi over 2 is less than A is less than 2 pi. Well, how do you remember that? Well, you remember that this is 0, this is 90 or pi over 2, this is 180 or pi, and this is 3 pi over 2. So this says it ends in quadrant 3, right there. Well, quadrant 3 is between pi and 3 pi over 2. So hopefully you got that. Express the product of the cosine of 135 and the sine of 315 in simplest radical form. That means if you come over here and go, geez, wonder what the cosine of 135 times the sine of 315 is? Oh, look. Oh, crap. It's 0.5. All right, so you can cheat, I guess, on this problem. But I'm going to switch it. So if you download this, I'm switching this. So I'm going to make this sine of 300. In fact, I'm going to pause right now and go do that so that this becomes a more difficult question. As you can see, I just made this change to make it sine 300. So if you're watching this and you downloaded the document, yours should already say 300. And you're probably wondering why I went through all that. Okay, so anyway, cosine of 135. Well, that's in the second quadrant, and I know cosine is negative over here. So whatever this is, it's going to be negative something. Now, I got to think about what its reference angle. So 180 minus 135, that's 45. And I have memorized, because you should by now, that the cosine and sine of 45 degrees is the square root of 2 over 2. So in this quadrant, it's negative. Now, the sine of 300. So 300 is down here. I'll do sine in red. 300 degrees is right here. Well, that reference angle is 60. Now, if I think about it, let's see. The sine of 60, first of all, in the fourth quadrant, we know we're negative because it's sine of 300. And the sine of 60 is the square root of 3 over 2. So my answer in simplest radical form is positive the square root of 6 over 4. Done. 22. Find algebraically the measure of the obtuse angle. So what you got to do is you got to solve this. So I'm going to divide by 3. I'm going to divide by 3, and I get cosecant of theta is equal to 5/3. Now, it says solve algebraically, so you have to show this next step. We're going to slide this over so we get theta by itself. And we're going to, really what we're doing is we're taking the inverse cosecant of each side. But we're just going to slide that over, make it inverse cosecant of 5/3. Now, I've done all the work that I can do. They don't expect you to know this algebraically in your head. That's not possible. There's not anybody that knows that. So we're going to go inverse cosecant of 5 divided by 3. But I did need to show that work. 36.869. So theta is equal to 36.869. Rounded to the nearest tenth of a degree, my answer is theta equals 36.9 degrees. Done. Uh-oh. Prove. Now, if you remember correctly and you're doing proofs, you can't mess with both sides. You can only mess with one side. So this side we're going to leave as equals cotangent. Now, I'm going to think about it, though, real quick. Isn't cotangent cosine over sine? So really what I want to try to see if I can make that cosine over sine somehow. So here's how we're going to do it. Tangent squared is sine theta over cosine theta. Now, what you want to try to do with most of these is to always try to get everything in terms of sine and cosine. Cosecant theta is 1 over sine squared theta. Now, this thing on the bottom here, 1 plus tangent, that's one of those ones I told you had to memorize. Remember it right up here? 1 plus tangent is secant squared. Told you this stuff comes back sometimes. So this is really secant squared theta. And we're not testing the right side, so we'll leave that out as cotangent theta. Now, let me go through a little bit of work. This cancels with one of those. Okay. Now, that's not that helpful. So in the numerator, what I have is 1 over cosine theta sine theta. And in the denominator, what I really have is 1 over cosine squared theta. But don't forget, when you divide by a fraction, we really flip and multiply. So this is really cosine squared theta over 1. Now I'm going to do my final simplifying. This cosine cancels with one of these, leaving me cosine theta over sine theta. And this, I just kept cotangent theta coming along. So cotangent theta is equal to cotangent theta. I know, that's everybody's favorite thing to do. Quite honestly, it is one of my favorite things to do, but I know you guys hate it. Oh, prove again. Okay, remember what I said. Try to make everything into terms of sine and cosine. So this will be 1 over cosine. Now, if you don't remember that secant is 1 over cosine, you got some studying to do, bro. Now we're going to distribute that. And we're going to multiply that times sine of theta. That's what this is. And then I'm also going to do plus 1 over cosine of theta times cosine of theta. Because that's what this is. Well, 1 over cosine times sine is really sine theta over cosine theta. Plus, and then these cancel. It leaves me just 1. Well, this sine over cosine is really tangent theta plus 1 equals tangent theta plus 1. Ka-ching. Love this stuff. Prove the identity. Now, this is another one of the ones you had to have memorized. Cotangent squared of whatever, that's beta, plus 1 is really cosecant squared theta. So this is really cosine squared beta, times, now what is cosecant? Isn't that 1 over sine squared beta? Now, if I multiply these, I get cosine beta squared over sine squared beta. And yes, lo and behold, that's cotangent squared beta is equal to cotangent squared beta. Now, don't fret over what symbols there. You can put anything there. You can put a big pizza for all I care. Express the following as a single fraction in simplest form for all values of x, which it is defined. Blah, blah, blah. Simplify, which means get rid of all the weird stuff, make it all sine and cosine. So this is sine x, thank God they used x, over cosine x times cosine x over 1, all over 1 over sine x. But don't forget, when we divide by a fraction, we're really multiplying by its reciprocal, sine x over 1. All right, let's see what cancels. These cancel, and I'm left with sine squared x. Done. That was easy. Show. Again, just get rid of all the weird stuff. Make them sines and cosines. So this is 1 over sine x, that's this, times cosine x over 1, that's this, times sine x over cosine x. And I want to show that this is equal to 1. Well, that should be pretty easy. Thought I switched colors. Sine cancels with sine. Cosine ends with cosine. I get 1 equals 1. Ka-ching. We got any more? Got any more? I hope so. Shoot. Oh my golly, I did not leave you enough room for this problem. We're going to be using stuff all over the place. So here's what we got, my brothers and my sisters. First of all, we have this formula, which is on our formula sheet. And the way this formula is written is it becomes cosine A times cosine B plus sine A times sine B. And then I know some of these. I'm almost halfway through here. I still have the hard problems to go. I know that sine A is 12/13. 12/13. I know that sine B, I don't know nothing about sine B. Cosine B is -3/5. That's a 5. So I have some work to do. So let me think about angle A. Angle A is in the first quadrant. So I'm going to draw a triangle in the first quadrant, a right triangle. And I was told that sine, which is opposite over hypotenuse, is 12 over 13. So 12 over 13. Now I hope by now you know these Pythagorean triples, that this is a 5. But if you don't, you just do x squared plus 12 squared equals 13 squared. And you'll find out that x squared is equal to 25. So this is 5. So now I can figure out what cosine, because remember this is angle A. I can figure out what cosine of A is. Cosine is adjacent over hypotenuse, which is 5 over 13. We're going to do the same math for cosine of B. Now B is in quadrant 2. And we were told that this is negative 3 over 5. Now you should definitely know your 3, 4, 5 right triangle and know that this is really a 4 here. Why did I put the 3 here and the 5 here? Because cosine is adjacent over hypotenuse. So the sine of B is 4/5. Well, this is negative 15 over... Well, quite honestly, I wouldn't do it this way. I would just type the whole thing into your calculator. Oops. I just go to your calculator and I do parentheses 5 divided by, lost track, 5 divided by 13 times, parentheses, negative 3 divided by 5 plus, parentheses, 12 divided by 13 times 4 divided by 5. Hit enter, and I get 33 over 65. Yay! Done! Got a graph, find the midline, gotta find the midline. Got to find the midline. It is absolutely imperative. The highest this goes is 8. The lowest it goes is 2. That's a difference of 6. 3 up, 3 down. That makes 5 my midline. So it has to be one of these two. Now, if that's the midline, that means we're starting at a min and ending at a min. If it starts at a min and ends at a min, it has to be a negative number in front, not a positive. All right, that's it. That was that one. Which equation below had a period of 8 pi? Well, you need to remember that period is equal to 2 pi over b. And I'll highlight all the b's for you. B, B, and B, and B. So what I want this to turn out to be is 8. So I need this to get bigger, which means I need to divide by a fraction. So it's got to be either 1/2 or 1/4. So if I divide by 1/2, that's the same as multiplying by 2. That would be 4 pi. Dividing by 1/4 is the same as multiplying by 4 over 1, which would be 8 pi. And so that's why. That's the answer. Approximately how many degrees does 5 radians have? Do you notice that there's no pi in this answer? It's just 5 radians. So you just put 5, no pi. It's just 5. And to convert from degrees to radians, you have to multiply by 180 over pi. Now, I have kids that just don't want to put that pi in their calculator. You just come over here and you go 5, parentheses, control, division, 180 divided by pi. Bam. Enter. 2. Now it says how many degrees? Approximately how many degrees? So I guess we're going to round to the nearest degree. It's equal to 286 degrees. Done. That expression is equivalent to. I'm going to show you 2 ways to do this problem. I'm going to show you the easy way and the harder way. No, I'm going to show you the harder way, then the easier way. So, sine is, or tangent is really sine of x over cosine of x divided by secant, which is 1 over cosine. But when you divide by a fraction, you're really flipping and multiplying by the reciprocal. So I'm really going to multiply by cosine x over 1. Notice the cosines cancel, and I'm left with sine. Don't like that? Give me an angle measure. Oh, 15 degrees. Great. I'm going to come over to my calculator and I'm going to do control division. Tangent of 15 over secant of 15 and hit enter, and I get some ridiculous decimal, and then I'll just do sine of 15. Oh look, same ridiculous decimal, right answer. All students take calculus. Anytime you get one of these, all students take calculus. Everything's positive. Students, sine positive, tangent positive, take calculus, cosine positive. Don't forget with this one, cotangent is also positive. With this one, secant is also positive. And don't forget with this one, cosecant is also positive. So this means negative. Where is cosecant negative? Let me grab some highlighter. No, not highlighter. Let me grab some blue. Cosecant's negative here and cosecant's negative here. Where is is this the same bloody problem? I think I did this problem, but cotangent is positive here and here. Choice 3. I think I did that problem already. So I'm going to change this. I'm going to change this to, so I'm going to delete a couple things. I'm going to delete this. And I'm going to delete this answer. And I'm going to delete that. And I'm going to change this right now to less than 0. And tangent or cotangent is less than 0 here and here. So that would be 4th quadrant. And I'm going to go make that change right now. You guys are going to watch me do it. It's question 33. And just like that, the answer is choice 4. Hit Control S. And now I go back to work. Okay, so what is the period? Period is defined as 2 pi over b, and this is b, so 1/3. So it's 2 pi over 1/3. Dividing by a fraction, same as multiplying by the reciprocal, 6 pi. Done. When does cosecant minus, okay, so I'm going to solve this algebraically. So just like before, you got to just show your work. Cosecant x minus the square root of 2 equals 0, or cosecant x equals radical 2. I'm going to take the inverse cosecant, or I'm going to bring this cosecant over, of the square root of 2. So I go to my calculator, and I do inverse cosecant of radical 2. And I get 45 degrees. So the answer is 45 degrees. But don't forget, on these, you usually will get 2 answers. Oh my goodness. I am a moron. I'm going to come back to that problem. So 45 degrees, where else is cosecant positive? Cosecant is positive in the first and the second, because that's where sine's positive. So in the second quadrant, that's this angle, it's 135 degrees. Let me go back to this bad boy up here. I got 36.9, but I forgot that I have to do, where else is cosecant positive? In the second quadrant. So I also need to do 180 minus 36.9, and I get 143.1. So my other angle is 143.1. Yeah, you got to try to remember, don't forget that always when you're solving these, almost always, you're going to get 2 answers, not just 1. Sorry about that, kids. I hope you figured it out that I was an idiot and fixed it. Now, why am I doing cosecant again? Oh, I know why. So anyway, cosine of 2c is equal to 1 minus 2 sine squared c, or 1 minus 2 times 2/3 squared. So let's see, that's 4/9, that's 8/9, that's 1/9 as an answer. Done. You just put in your calculator. Max of 2, min of -2, we're going to start at a max and end at a max. So we're starting at maxes. That means it can't be sine. It's got an amplitude of 2. Good. Now here's the hard part. It finishes one full curve in 2 pi. That means its period is equal to 2 pi over 3. I'm sorry, I misspoke. It finishes one full curve in 2 pi over 3. That doesn't mean the frequency is 2 pi over 3. That means it finishes one full curve in 2 pi over 3. Well, this is equal to, don't forget the formula for period is 2 pi over b. Well, we just said that's 2 pi over 3. So doesn't that make sense that b has to be 3? And remember, this is the b value. So there's your answer. Boy, that was a tricky question because I'll bet there's a lot of kids that want to pick this. Not right. All right, I'm going to do a 5 or 6 of these, it looks like. Remember, cofunctions are equal when their angles are equal to each other. So I'm going to do the first 3 showing you, and then I'm going to do some speed work. 3a plus 32 plus 7a. Did I say that they have to be equal to each other? I misspoke. It's so easy to do that. They have to add up to be 90 degrees. So this gives me 10a plus 20 equals 90, or 10a equals 70, or a equals 7. Next problem. I'm going to show you again. I'm going to show you a few. They have to add up to equal 90 degrees. So 5a minus 15 plus a plus 21. Now it only works if they're cofunctions like sine or secant and cosecant. Has to equal 90 degrees. So that's 6a plus 6 equals 90. 6a equals 84, and then therefore a is equal to, I think it's divided by 6, 12, 14. I meant 14. I meant 14. A equals 14. So I'm going to speed things up a little bit. I'm just going to add them up as we go. So this is 7x plus 6 has to equal 90 degrees. Or 7x has to equal 84. Or x has to equal 12. Just doing it. So 16x minus 30 is equal to 90. Or 16x is equal to 120. Not really sure about that. 120 divided by 16. Oh, 15. So that's 7.5. X equals 7.5. You could leave it as 15 over 2 if you prefer. All right, so I did those. Find the exact value of this. So here's what the dummies do. The dummies go over here and they go sine of 75, enter, and they figure if they write all of those decimals out, that's the exact value. Wow. You clearly were not paying attention in class. Clearly. I have a few that did this. They make me want to knock them out, but I won't because I love them all so much. They're a lot of fun. I'm like Jordan and Pfenninger, smiling all the time. Right, Jordan? Right? All right, Paige. All right, here we go. So you can't do it that way. So what you got to do is you got to make 75. Now, any kind of these problems, any one of these problems is always going to be 45 and some other angle. So 45 plus 30. I know a lot about 45 and I know a lot about 30. But it's now an addition problem, which means I have to come over to my formula sheet and use this formula. Let me erase. Let me get this a little bit bigger. And I'm going to show you. We got to use this formula now. All right. So it's sine A cosine B, cosine A sine B. So we're going to come over. Forgot what I was doing. All right. Of course, I've got to make this big again. And I'm going to go to the right actual page. Ah! All right. And it's probably next to my big head, so let me move away from my big head. So this is equal to sine of 45, and the formula said sine of 45, times the cosine of 30 plus the cosine of 45 times the sine of 30. And that's what that formula said. Remember, this is A and this is B. So it said sine A, cosine B, cosine A, sine B. So now I just have a little bit of work to do. Sine of 45 is the square root of 2 over 2. The cosine of 30 is the square root of 3 over 2. Cosine of 45, square root of 2 over 2. Sine of 30 is a half. Huh? You don't have that memorized? Just go like this. No, don't do that. You don't have to do that. You just have to memorize. Now, if you don't memorize, come over to the calculator. Maybe we can make this calculator sing for us. Ooh, that's nice and big, but it's going to be right next to my noggin, so I'll try to make it a little bigger. All right, maybe that's going to help. So you don't know. Let's go sine of 45. I don't remember. Is that the square root of 3 over 2? Nope. Is it the square root of 2 over 2? Oh, yeah. So the sine of 45 is the square root of 2 over 2. Now, while I'm here, let me think about cosine 45. I think that's the same. Oh, yeah, that's the same. So I come over here and I go, oh, yeah, cosine and sine are both square root of 2 over 2. Now, cosine of 30, I don't remember that one. I don't remember cosine of 30. Cosine of 30. Oops. Cosine of 30. 0.866. Wait a second. Wasn't that the square root of 3 over 2? Oh, look, square root of 3 over 2. And you do the same for a half, and you get it. So now the trick is here knowing how to multiply fractions. Square root of 2 times the square root of 3 is the square root of 6 over 4 plus square root of 2 over 4. I got to express it as a single fraction, so it's the square root of 6 plus the square root of 2 over 4. And that's the answer. Now, can I check that to make sure it's right? Absolutely. Control division. The square root of 6 minus, oops, I think it was plus the square root of 4, square root of, oh my gosh, why do you hate me so much? So, plus the square root of 4, square root of 2, all over 4. So that was the answer. Holy mackerel, that took forever. And what was it? Sine of 47 to 75? Oh, look. The exact same decimal. So I know I got it right. This is the right answer, though. Okay. Find the exact value of sine of 105. Don't forget what I told you. Okay. It's all about converting it to angles we know. This is the sine of 45 plus 60, because 60 plus 45. So it's the same formula, because we're adding. So we're going to take sine of 45 times the cosine of 60 plus the cosine of 45 times the sine of 60. Now, cosine of 45 is square root of 2 over 2. The cosine of 60 is a half plus this is the square root of 2 over 2, and this is the square root of 3 over 2. Again, you either memorize them or you go use your calculator to help you cheat. This is the square root of 2 over 4 plus the square root of 6 over 4. This is equal to, finally, the square root of 2 plus the square root of 6 over 4. And no, those can't be combined. And no, when you add fractions, you leave the denominator over 4. Evaluate the exact value of the sine of 13. This should be 13 pi over 12. Now, there's a couple of ways to do this, but I'm going to revert back to degrees. I got to figure out what this is as far as degrees goes. So control division, 13 pi over 12. Now, to convert from degrees to radians, or from radians to degrees, I multiply by I multiply by 180 over pi. Oh, it's 195 degrees. Okay, so I come back over here, and this is really the sine of 195 degrees. So what I need to do is make that. Well, that's the sine, and it's always going to be 45 plus, in this case, 150. It's always 45. So just subtract 45 and see what it is. So this is equal to the sine of 45 times the cosine of 150. We're going to have to be careful. Plus the cosine of 45 times the sine of 150. Now, sine of 150 and cosine of 150, that has a reference angle of 30 degrees because 180 minus 150 is 30. So let's go. Sine of 45 square root of 2 over 2. The cosine of 30 is the square root of 3 over 2, but it is 150. And that's in the second quadrant. And cosine is negative in the second quadrant. Be careful. Plus the square root of 2 over 2 times, now the sine of 150, the sine of 30 is 1/2. So we're almost done. We get negative radical 6 over 4 plus radical 2 over 4. And are you saying there's a lot of radical 6s and radical 4s and 2s and things like that? Yeah, it's always like that with these problems. So it's negative radical 6 plus radical 2 over 4. All right, now we got a cosine. I got to make 165. So I know that's 45 plus 120. So the cosine formula is cosine 45 times cosine 120 minus, this is the cosine formula, sine of 45 times the sine of 120. All right, this is going to be negative because we're in the second quadrant. So I'm going to just do that right now. This is just the square root of 2 over 2 minus, this is the square root of 2 over 2 times sine of 4. Let's see, this has got a reference angle of 60 degrees. And I know the sine of 60 is radical 3 over 2. And sine's positive in that quadrant. The cosine of 120, again, the cosine of 60 is 1/2. So this is 1/2. So this is negative radical 2 over 4 minus radical 6 over 4, which is negative radical 2 minus radical 6 all over 4. All right. Wow, we got more of these? All right, well, that's the last one of these, I think. So this I got to make 345 degrees. So it's always 45 plus 300. So this is, the cosine formula is cosine 45 times the cosine of 300 minus the sine of 45 times the sine of 300. All right, let's see what we got here. This is radical 2 over 2. Sine of 300, that's a reference angle of 60, and the sine, or the cosine of 60 is 1/2. And cosine in the fourth quadrant is positive. Minus square root of 2 over 2. Now, sine in the fourth quadrant is negative, and the cosine of 60 is the square root of 3 over 2. So this becomes radical 2 over 4 plus, see the negative, make a positive, radical 6 over 4. And this becomes radical 2 plus radical 6 all over 4. All right. We do have a cosine formula that has just got cosine in it. It's right here. It's 2 cosine squared a minus 1. So when I go back here and I say, okay, I want to replace this. Well, I can replace that with 2 cosine squared theta minus 1. Well, this is cosine theta. So this is 2 times 8 over 17 squared minus 1. I'm not even going to try to do that in my head. 2 parenthesis, control division, I forgot what it was. 8 over 17. I am going to do this in my head, by the way. Squared minus 1. Let's see, that's 64 over 289. 128 over 289. It's like 241 over 289. Or, oh yeah, negative, no, sorry. got my head up my keister. Negative 161 over 289. I had the 289 right. Negative 161 over 289. Catching. Oh, we're going to go do any of these. All right, so that looks like one of my formula sheet. 1 minus 2 sine squared and some angle. Isn't that on my formula sheet? Oh, yeah, it's right here. It's really cosine of 2, whatever that angle is. So if I go back, this is really cosine of 2 times the angle. Well, that angle is pi over 6. Well, 2 times pi over 6 is really cosine of 2 pi over 6. Now, if I convert 2 pi over 6 to degrees by multiplying by 180 over pi, you would find out quickly that this is 60 degrees. So this is really equal to the cosine of 60 degrees, which is equal to 1/2. Now this looks like one of my formulas. Cosine, cosine, sine, sine. I know that's one of those cosine formulas I just did. Cosine, cosine, sine, sine. Was it plus or minus? It was a plus. So I come over here. Here's the one with the plus. Let me highlight this one. Here's the one with the plus in it right here. So that's really cosine of the two angles being subtracted. So this, let me get out of my big head's way, is really equal to cosine of 50 minus 30, because those two angles being subtracted. So that's the cosine of 20. Now you could check that in your calculator. I'm not going to. All right, let's get booging. So I think we got 8 questions left. 9, 10 questions left. Oh my God, 10 questions left. And all the hard ones left. So I need to find all the angles. Now here's something I got to highlight for you because I want to make sure you understand something. Your answers all have to be in radians because that's in radians. So whatever answer we give have to be in radians, but this says round to the nearest minute. So I'm going to get rid of one of those two because normally this would mean you have to give your answers in the nearest radians. And then this says round to the nearest degree. So if the answers don't turn out to be nice, we're going to do the nearest minute. I don't know how these answers are going to turn out. All right, I need to replace this. And because I've got nothing but signs, I'm going to replace it with that 1 minus 2 sine squared theta. Because that's on my formula sheet. Right there. So now plus sine theta equals sine squared theta minus 1. Well, I want to make sure my squared's positive, so everything's going to the right. I'm not going to have anything left on the left, so it's 0 equals. Now, when I add this to sine squared theta, I get 3 sine squared theta minus sine theta. Now, I'm going to subtract 1. I get minus 2. Hopefully, this thing factors. 3 sine theta and sine theta. And this has to be plus 2 and minus 1 because those multiply to negative 3. So that's the right answer. So this gives me sine of theta equals negative 2 over 3. And this one gives me sine of theta equals 1. So I am going to change this from 0 to 360. I'm going to do that right as we speak. But be careful. If it does say 0 to 2 pi, your answers have to be in radians. It would never do what I did here and be all crazy and say one and then tell you the other. So for the sine equals to 1, I'm going to draw the sine curve up and down and up. So remember, this is 0, 360, 180 is in the middle, 270, And my answer, where sine equals 1, is 90 degrees. So one of my answers is 90 degrees. This one's going to give me two others, but in the third and fourth quadrant. So I come over here, and I'm going to do inverse sine of positive 2/3. And I get 41.81 degrees. But I don't want that one. I want the ones in the third and fourth quadrant because that's where sine is negative. So I'm going to add 180 to this because that gets me in the third quadrant. And I'm going to take 360 and I'm going to subtract off that 41.8. Now, I think it said to the nearest minute, so I got to DMS these. That's going to be 318.11. So 318.11. And then my other one is going to be 221. Now that cutoff is 37, so we got to round that up. So it's 221.49. So 221 degrees 49 minutes and 318 degrees 11 minutes. All right. One down, 9 to go. I have to replace anything that says 2 theta. I can't do anything with 2 theta. And sine of 2 theta, if you forget, it's right there. There's only one formula. It's 2 sine theta cosine theta. So, how do I keep doing this? So this becomes 2 sine theta cosine theta minus cosine theta equals 0. Factor out the GCF. Take out the cosine theta. You're left with 2 sine theta minus 1 equals 0. Those I'm going to set equal to 0. So cosine theta equals 0 and sine theta equals 1/2. Now for this cosine theta equals 0, I'm going to draw my picture. Remember, 0, 360, 180, and then 90 and 270. And 90 and 270 is where cosine equals 0. So those are two of my answers, 90 degrees and 270 degrees. Sine is equal to 1/2. I remember sine is equal to 1/2 at 30 degrees. And in the second quadrant, because if you inverse sine this, you'd end up with sine equal 30 degrees. But I also need the one in the second quadrant, and the one in the second quadrant is 150 degrees. All right, so I need to, wait, isn't this the same problem I just did? Yes, so this one's got to go, because I already did this one. Yay, did that one. All right, so I'm not allowed to have mixed trig functions. I can't have a sine and a cosine, and the only thing you can replace are the ones with 2 theta or squareds. And I got to remember that cosine squared plus sine squared is equal to 1. If I remember that and I bring this cosine squared over, sine squared is equal to 1 minus cosine squared. So this becomes 2 times 1 minus cosine squared x, or theta, plus 5 cosine theta plus 5. Now notice everything is in terms of cosine theta. I have to distribute the 2, so I get 2 minus 2 cosine squared theta plus 5 cosine theta plus 5 equals 0. Now I got to move everything to the right side because I can't have a negative squared term. So 0 is equal to 2 cosine squared theta minus 5 cosine theta. Now these two make 7. So minus 7. This seems like it's going to be something that's not going to factor. But maybe I'm going to get lucky. It is 2 cosine theta minus 7 plus 1. Yes. So I get cosine theta equals 7 over 5. And cosine theta is equal to -1. Well, if you try putting this in your calculator, you're going to get some interesting stuff happening. So we're going to do inverse cosine of 7 divided by 5, crash. You remember, you can't take the cosine of something bigger than 1. Now, for the cosine equal to -1, we're going to draw the cosine curve. Where does it equal -1? Right down here in the middle. So the only answer to this is 180 degrees, not 108. Done. So we're going to replace this with what it's equal to, but because I've got cosine over here, I want to replace it with just cosine. So this becomes 3 times 2 cosine squared theta plus 1 plus 17 cosine theta equals 0. Now some of you are like, where did this come from? Don't forget, let's go back to the formula sheet. It's right here. Cosine 2 theta is 2 cosine theta minus 1. So that's all I did was I came and replaced this, just this, and that becomes this. So I'm going to distribute my 3. I get 6 cosine squared theta plus 3 plus 17 cosine theta equals 0. I have a mistake, though, I made. I want to erase it. This formula, and I knew something was not going to work out, minus, that's a minus. So what I have here to factor is 6 cosine squared theta plus 17 cosine theta minus 3 equals 0. 6 cosine theta and cosine theta. And this would be plus 3 and minus 1. So this gives me, I'm not helping you with the factoring. That's not what this thing is. Cosine theta equals 1/6. Cosine theta equals -3. We just said you can't be bigger than 1 or less than 1. So if we got 1/6, we'll come over to our calculator and we're going to do this to the nearest degree. Thank goodness. So inverse cosine 1 divided by 6. 80.4. So my answer is 80. So theta equals 80 degrees. But cosine is positive in the first and fourth quadrant. So my two answers are going to be 80 and 360 minus 80, which is 280. So those are my answers. Now you remember, we're not allowed to have mixed functions. So I've got cosecant and cotangent. And I don't want that. Thought I paused it. Okay. Cosecant and cotangent. I don't want that. So I have to remember that cosecant is really cotangent squared theta plus 1. And then plus cotangent theta minus 7 equals 0. Now I just clean it up and factor. But you have to remember that one thing. So cotangent squared theta minus cotangent theta minus 6 is equal to 0. I'll factor this bad boy. This is cotangent theta minus 3 and plus 2. So I get cotangent theta is equal to -2 and cotangent theta is equal to 3. And everything else, cosine and sine can't be bigger than 1, but all the others can be. Now this one is going to be in quadrants 2 and 4, because that's where cotangent's negative. And this one's going to give me answers in 1 and 3. And since I didn't say, let's round to the nearest degree, just to make our life easy. So let's do the first one. Cotangent inverse of 2. 26 point, and we're going to round this. So it'll be 27 degrees. So theta is equal to 27 degrees. Now, I don't want that one. I want the one in the second. So I'm going to subtract from 180. And the fourth. So I'm going to subtract from 360. So 180 minus this, which is 153 degrees. Oops. And 360 minus this. And I get 333 degrees. So those are my first two answers. 153 and 333. I think that's what they were, right? Yep. Now I'm going to do cotangent inverse of 3. So I'm going to do cotangent inverse of 3. I want this angle, 18 degrees. I also want the one in the second quadrant, or the third quadrant. So I'm going to add 180 to it. So 18 and 198. 18 degrees and 198 degrees. 4 left, kids, 4 left. I can't have a sine 2 theta, so I have to get rid of that. Cosine theta minus 2 sine theta cosine theta. Now, if this looks like a problem we did earlier, I think it is, but we're going to do it as a part 1. I don't know. Take out the cosine theta. I'm left with 1 minus 2 sine theta. I'm really certain we did this problem earlier as a... The only reason I'm looking is because I'm trying to reduce this down to 8 pages. Well, whatever. All right, so this gives me cosine theta equals 0, and this one gives me sine theta equals 1/2. Well, cosine theta is equal to 0 at 90 and 270, so those are two of my answers. 90 degrees and 270 degrees. And it's equal to at 30 and 150. I think I just did this problem. I don't know, whatever. It's slightly different. It's slightly different. So this one's 30 degrees and 150 degrees. No worries, we're done. 3 left. Secant squared theta. You need to remember that you have to replace it. Now, the only way it's going to work is if it's something with tangent. So you got to know it's something with tangent. It's tangent squared x plus 1 minus tangent x equals 11. So this becomes 6 tangent squared x plus 6 minus tangent x minus 11 equals 0. So 6 tangent squared x minus tangent x minus 5 equals 0. Let's factor this puppy. We're almost done. Let's go 6 tangent x and tangent x minus 1 and plus 5. All right, so this gives me tangent x is equal to negative 5 over 6. Now, tangent is negative in the second and fourth quadrant, so we're going to have to find those. And this one gives me tangent x equals 1. Well, that's one I have memorized, 45 degrees. And tangent's also positive in the third quadrant, and so I take 180 and add 45, and I get 225. So now I just need to find these. So I'm going to inverse tan 5/6, and I get 39.8. So it's like 40 degrees. Oh, round to the nearest minute. But I don't want that one anyway. So I want the one. So I got to subtract from 180. So I'm going to take 180 and subtract this. And I'm going to DMS it. So I get 140. Remember that 30s are cut off. So 140 degrees, 12 minutes. 140 degrees, 12 minutes. And I'm also going to take 360. I'm going to subtract off that 39 degrees. And I'm going to DMS this. And I get 320, 12. 320 degrees, 12 minutes. There they are. 2 left, kids, 2 left. Here we are. Now, the only way this is going to work is if this converts to something with cotangent. So, it does. By the way, did I already do a secant? Nope. Okay. So, this becomes 8 times cotangent squared theta plus 1, because that's what cosecant squared theta is, minus 3 cotangent. If these look familiar, it's probably because I've done them a million times, these same problems. There's so few problems. There's an infinite number of problems, but they take forever to make. So I get 8 cotangent squared theta. Is not an infinite number. There's a lot of them, though. Plus 8 minus 3 cotangent x minus 13 is equal to 0. If I'm moving too fast for you, please, you're going to have to rewind. You're going to have to pause. 59 problems take forever to get through. So we're going to do 8 cotangent squared theta minus 3 cotangent theta. I should be using x, not theta. Let's see, minus 5 equals 0. So now I got to factor this puppy. I'm going to use 8 cotangent x and cotangent, only because 8 minus 3 is 5. So plus 5 and minus 1. That's negative 8 minus 5. So that's it. So I get cotangent, when I solve these, I get cotangent x equals negative 5 over 8 and cotangent x equals 1. Well, I know that one's 45. That one's going to give me the same as the tangent. So tangent and it's 225. The other one, I don't have a clue, and I got to do this to the merest minute, but I know this is going to be in quadrants 2 and 4 again. So I'm going to inverse cotangent 5's 8. 5 divided by 8. And I don't want that one. I want the one in the second quadrant. So I'm going to take 180. I'm going to subtract off this angle and DMS it all at the same time, just because it's so much fun. So 122 degrees, 19 seconds. Don't round. So 122 degrees, 0 minutes. Wait, is that right? Yeah, 122 degrees, 0 minutes. And the other one's going to give me, let's do this, 360 minus, and we'll DMS it. I think it's 302. 302 degrees, 0 minutes. 302 degrees, 0 minutes. All right, one last problem. I don't know why those parentheses. Again, I have secant squared and tangent. You can't have mixed ones, and the only things you can replace are secants, squareds, and double angles. So I'm not going to replace the tangent. So this becomes 2 times secant squared is tangent squared theta plus 1 minus or equals 5 minus tangent theta. So this becomes 2 tangent squared theta plus 2 is equal to 5 minus tangent theta. So I want everything to the left side. So 2 tangent squared theta plus tangent theta minus 3 is equal to 0. Now we'll do the factoring. 2 tangent theta minus plus 3 and minus 1. So I get tangent theta equals negative 3 over 2. And once again, I get tangent theta equals 1. I've memorized that that's 45 degrees in the first quadrant, 225 degrees in the third quadrant. I just got to do this 3 over 2. So inverse tan, nope, not tan, inverse tan of 3 divided by 2. Okay, I got 56.3 degrees. I'm rounding the nearest minute, but I don't, negative is in the second and fourth quadrant again. So once again, I got to do 180 minus this answer and DMS it. And I get 123.41. 24 is not enough to cut it off, so it's 123.41. 123 degrees, 41 minutes. And then I'm going to take, remember, 30 is the cutoff. So then I'm going to take 360. I want to subtract off this and DMS it. And I get 303.41. So 303 degrees, 41 minutes. Kids, you just went on an hour and 40-minute adventure with me. Now, I know most of you didn't hang around for that entire hour and 40 minutes, but that's an hour and 40 minutes of review. Hopefully you did it over a little bit of time. Hopefully it makes more sense. The more you work, the better you're going to do. It's all about you. What you going to do? What do you have the maturity to do? How much work? Now, you don't have to do it all. You don't have to do it all. Well, if you're hoping to pass, just pass. You need to work as hard as you can. If you're hoping to get 100, you need to work as hard as you can. You should all be working hard. All right, guys, that's it. If you appreciate the hour and 40 minutes I just spent with you, hit subscribe. If you already hit subscribe, hit the thumbs up. If you already hit the thumbs up to you. Nice job. Love you guys. Good luck on this Regions. If you get 100, email me at kenkraus@gmail.com. I still don't have my site up, page up. I will. I guarantee it. Good luck, guys. Keep working hard. It's almost over. Bye.